Okay, so day 3 in our derivatives unit here. And we have basically 3 main areas that we want to look at today. And that's, I'm going to give you the shortcut method to the power rule of derivatives. And we're going to look at examples that involve using polynomials and roots. Equations are y equals a polynomial of some kind, or y equals a root expression of some kind. And then we're going to use the power rule of derivatives to do that. And then we're going to do an example that has slope and lines in them, because we know the derivative represents a slope of a tangent line at that particular curve that you're dealing with. Now, day 4 is going to be a work period for practice, so there'll be no practice today as such. It'll come up tomorrow, so you'll have a whole period to work on it tomorrow. As a result, today's video will probably be a little longer than 30 minutes. I'm guessing around 40 to 42 minutes is what it has been in the past. And let me just get my timer out here so I can time myself. Started a little late, but that's okay. And so what we're going to do is we're going to do those main 3 things today, do the instructional stuff today, and the practice video, work will be tomorrow for you. So let's get ahead and let's give the derivative a power rule, the shortcut rule. You probably, as you did last assignment, probably found or realized or maybe saw a pattern in there, and you maybe have it figured out already. Okay, so let's go ahead and change to marker here. Okay, and let's make sure that we got this. Okay, so if you're doing the power rule, for derivatives. Okay, so you might have figured it out already. Okay, so if y is equal to some value of x to the power of n, then the derivative of that, which we'll call y prime, is equal to just simply you put the power out front of the x, and then you subtract 1 power away from the x, like that. So that is the basics of it. Now, if you have a constant in front, okay, so like you have 3x or 4x or 5x or 6x, the constant stays in there as well. So if you had y equals, like c is a number, xn like this, so that could be 3, 4, 5, whatever it might be, then the derivative, or y prime, would equal same thing, n, but the c stays there, x n minus 1. So that c stays in there for your constant. Okay. If you take the derivative of a constant with no x value, there is no derivative. Okay, and then y prime is 0. So the derivative of 5 is 0. The derivative of 6 is 0. The derivative of 5x is 5. But the derivative of 5 is 0. And that's kind of how it works. So let's do some examples here of this. I'll just get my notes, my examples that I'm going to try. So let's go ahead and do a few examples in here using this power rule idea. Okay, so let's say we had a y. Okay, I'm going to slide this up a bit here. So examples. Let's start with polynomial ones. Okay, so if I had 3x to the power of 7 minus 4x to the power of 5 plus 2x minus 8, y equals. Okay, so if you have addition in between or subtraction in between, you can treat each as a different power. So you can do the derivative of each. So we're going to remember that y prime is equal to n c x n minus 1. Okay, so 7 is the n value. Okay, so if we're doing y prime, we take the 7 out front, then we multiply it by 3x 7 minus 1. Now you're not going to write that out all the time. You're going to do shortcuts, but I'm going to write it out at the beginning when we're starting this. So we got minus 4 times 5x 5 minus 1 plus 2. Okay, this is interesting. 2 out front, and then we go x x to the power, x by itself is x to the power of 1. Okay, 1 minus 1 minus, there's no x there, so that's 0. So now if we do this one, we get 21x to the 6th minus 20x to the 4th. Okay, now you have to remember that x to the power of 0 equals 1. Anything to the power of 0 equals 1. So this is just 2 times 1 plus 2. And then this is minus 0. So we don't have to. So there is our derivative. So basically, if you're doing it shortcut way, 7 times 3, 21. 7 minus 1, 6. Negative 20, 5 minus 1, 4. Okay, this one here, 2, because 2 times 1, 2. And then 1 minus 1, 0, which x is 0 is 1, so it's just 2. So 2x, 3x, 4x, 9x, anything that, it just gives you the number out front. Okay, so that's an example of polynomials. Let's do another example of a polynomial one here. Okay, if you want to pause the video and try it on your own, and then unpause it, that would be an okay thing to do as well. Okay, so let's say I had 8x cubed minus 7x squared minus 9x plus 12. Okay, if we're going to do this one, this time we're going to do without writing it out in front, just kind of working it out. Okay, y prime equals 3 times 8, 24, x, 3 minus 1, 2. Okay, minus 2 times 7, negative 14, x minus 2 times minus 1 is 1, so we can just leave it like that. Minus 9 times 1 is 9. 1 minus 1 is 0, so that's going to be there, plus 0. And there's your whole derivative. So you can do it that way as well. If you don't want to write out the particular formula, you can do that work in your head as well. I'm okay with that. Just be careful you double check and make no mistakes. You know, I will make mistakes. If you see me make a mistake, especially since this is a brand new video, making it in 2020 for the upcoming year. We're in that COVID thing right now, so I'm using my extra time here to make some new videos. So if you see any errors, please let me know, and I'll reference you on there, and I'll correct it on the video. Okay, let's do one more here. Actually, let's go into roots, because that's pretty simple. Well, maybe we should do one more. Let's do this one. Try this one. So let's say we had y equals 19 x squared minus x cubed. Okay. Sometimes they'll do it like that. So what do you get? Y prime, 19 times 2 is 38. X. 2 minus 1 is 1. Okay. Minus 3 times 1 is 3. 3 minus 1 is 2. X squared. There's our derivative. So doing these kinds of derivatives when there's just pluses and minuses in between, when you have an expression that is written as a polynomial, is simple. Nice little shortcut method. You don't have to use that long definition of a derivative. So let's go into our second type of examples. So these are examples that use root expressions, sometimes called radicals. Okay, so let's say we had, say, y equals the root of x cubed, okay, plus the cube root of x squared, let's say. What do I got here? My plus, let's do one like this, plus 1 over x squared. Okay, so you have to, basically, we have to rewrite the roots into fractional form. That's what we have to do before we do anything. So to remind ourselves, if we have the marker's kind of weird today, it's kind of floating around a little bit. But anyways, so if we remember, if you have something like something to the power n x to the power of m, this is equal to basically x to the power of fractional form, or exponent form is what I should put there, not fractional form. Let's change that, sorry, because roots and exponents go together. That's the wrong word. So it should be exponential. So remember, if it's got a number in there, that goes in the denominator, this goes in the numerator, so this would be m n. Okay? And if you have something like this, if you have 1 over x to the power of n, that's the same thing as x to the power of negative n. Two exponential rules, okay? Exponent rules, exponential form. So let's rewrite this equation here. So our rewrite is going to be, okay, so this is going to be x. Now, if there's nothing in the notch, it's square root, that's a 2. So this is going to be x to the power of 3 over 2. This is going to be plus x to the power of 2 over 3. Don't get those mixed up. And this is going to be x to the power of negative 2. And that is what our y equals. So there, that's our first step. First step is to rewrite it into exponential form. And then we're going to use the power rule. And I'm going to do the long form of the power rule by writing it right out. So now use the power rule. Okay, so the power rules, I'm going to put this out front. Y prime equals 3 over 2 x 3 over 2 minus 1, okay, plus 2 over 3 x 2 over 3 minus 1, plus negative 2x negative 2 minus 1. Okay, so that's the whole thing there. Okay, so just making sure that we are using the right expression here. Yep. Okay, we've got it rewritten. Now we have to do some simplification with these exponents up here. Okay, so this is going to be 3 over 2, 1.5x, but I'm going to leave it in fractional form. Okay, this is going to be 3 over 2 minus 1. 1 is 2 over 2, so this would be 3 over 2 minus 2 over 2. Okay, and this one's going to be 2/3 x, 2/3, and minus 1 is 3 over 3. And then plus 2x minus 3. Okay, so if we simplify this for our exponents, we get 3 over 2x to the power of 3 minus 2 is 1 over 2, 1/2. Now this is 2 over 3x. This is negative 1 over 3. And then finally, now some books, this is a good answer for the derivative. You can rewrite it back if you can convert it back into roots as well. Now this is good. This is a good answer. I'll accept it. But this can be converted to roots. Okay, so this would be 3 over 2. So 3, and then the x to the power of 1/2 is the root of x. That's that one. Plus 2, x to the power of negative 1/3. That means that the x is going to go on the bottom. If we want it to the power. Okay, and this has to go in the notch. Okay, it goes on the bottom because of the negative. This goes on the bottom if we want it positive. Okay, so that's another way we can write this. Now, do I require you to do this? No, but some answers will be in that way. And just to remind you that some of the answers in there, like I got this course from Mr. Friesen. He was developed it, and then I've done some changes to it, but I still use. He developed all the practice assignments. Well, not all of them, but most of the practice assignments and the answers. So he's worked them out, and I still use his answers in there. So sometimes he'll convert it back into here. Sometimes I'll leave it here. So there's both of us are doing it. So if you find an error in the answers, it'll be either him or I. Okay, so can be written like this, or can be written like this. Excuse me. They're both good answers. Okay, that's looking at what we had on tap here for today. That's looking at polynomials and roots. Okay, we'll do one more root example, and then we'll get into our final thing for today. Let's do one more root example on the next page here. Find the derivative. Okay, so there is that. I think I've got one here that will. So let's say I had y equals 3. Now that's a constant in front. X to the 5th minus 2x to the root of x plus 4 over x cubed. Okay, so let's rewrite it first. So this is going to be 3x to the 5 over 4. That's in the denominator. Minus 2x to the 1/2. Remember, if there's nothing in that root, that's a 2. Plus 4x to the negative 3, not negative 1/3, negative 3. Okay, now we can do the derivative, y prime. So this is going to be, I'm going to do this one, 5/4 times 3. And I'm going to write it as 3/1, x to the 5/4 minus 4/4, because 4/4 is 1. Taking a little bit of a shortcut there. Minus 2 times 1/2. So we'll go 2/1 times the 1/2. X 1/2 minus 2/2, which is 1. Okay, and then plus negative, plus 4, times -3, plus 4 times -3, x to the -3 minus 1. Okay, so this is 8/4, which we can reduce, or 8/4, what am I saying? 15/4. Can't read my own writing. X to 5 minus 4 is 1/4. Okay. Minus 2 times 1, 2, that's just 1. X to the -1/2. And this one is -12, x to the -4. Okay, so there's another example. Now we could rewrite this in root form, but I'm not going to bother this time, because that's a good answer. I usually leave my answers in fractional and root and exponential form, because they're easier to work with in calculus for most times. So that gets us a couple examples of using root forms, a couple examples of doing polynomials. And the third example that we have is doing examples that involve lines and slopes in them. And the first thing we have to remember here is to remember when they talk about parallel and perpendicular lines, because that can happen here with lines. So remember as well that parallel lines have the same slope, and perpendicular lines have a slope that are negative reciprocals. Okay, so what does that mean in terms of math here? So parallel lines here, just a straight 10, I think. Parallel lines, maybe it's 11, I don't know. Can't remember. Actually, I think it's grade 10 when it gets into parallel lines. So if one line is x, slope equals x. Or we'll use, not x, let's use m for slope, because we know m equals slope. Stupid me. M equals m, where m is slope. Okay, and perpendicular lines if you have one line, the other one is equal to 1 over m negative. Okay, so that's kind of the relation that we'll need to do. Okay, so let's do an example of that. Like I said, I think this one will probably go about 40 minutes or so. So let's do an example of that on the next page. Okay, so this example will be using let's say slope and line equations. Okay, remember that y equals mx plus b is also a slope line equation. So let's do an equation like this. Let's get it over here. So it's find the equation of the tangent line to the graph y equals 2, what do I got here? 2x cubed. I'll change those ones, plus 4x squared minus 5x minus 3 at x equals negative 2. Okay, so let's get these powers properly done here. No, that's the wrong one, Rob. Here we go. Let's do that again. There we go, that one. And that one. Okay, so there's our equation. So find the equation of the tangent line to the graph y equals 2x cubed plus 4x squared minus 5x minus 3 at the point x is equal to negative 2. So the first thing we want to do is to find the point on the curve. Okay? Step 1. Let's do this in blue. What is the value of the point on the curve that we're dealing with? We know that this is a cubic equation, so that's probably, and it's positive, so it's going to go like that, right? It's going to have that shape. And, oops, I forgot to cheat. So we know it's going to be like, probably like that. It can have two turning, something like that. And then at this point here, we're going to be like, what's the slope at that particular point? So step 1, find the point on the curve. That you're going to deal with. Where is it? So we're just going to plug it in there. Y equals 2 times negative 2 cubed plus 4 times negative 2 squared minus 5 times negative 2 minus 3. So this is equal to 2. Now negative 2 times negative 2 times negative 2 is negative 8. Plus 4 times negative 2 times negative 2 is 4. Plus 10 minus 3. So this is negative 16. This is positive 16. And this is plus 7. So that's going to give us 7. So we've got our point at negative 2 and 7. So probably up here somewhere, maybe over here. I don't know. It could be positive, negative slope. I don't know exactly. So that's our step 2. Step 2 now is to find the slope. At that point. Okay, so we do the derivative first. Y prime. Okay, so let's do the derivative. 3 times 2 is 6. X. 3 minus 1 is 2. Okay, plus 2 times 4 is 8. 2 minus 1 is x to the 1. And minus 5. And that's derivative of negative 3 is 0. Okay, so then the slope would be equal to 6 times negative 2 squared plus 8 times negative 2 minus 5. So this is going to give us our slope at that value. Okay. Let's do it. 6 times 4 minus 16 minus 5. 24 minus 21 equals 3. So this is our slope. So we've got our slope, we've got our point. Now we're going to find the equation of the tangent line with that given slope that has that point that it's contacting. So let's say it's here. It's going to be that line that we want the equation of. So this point is on it, and it has this slope. So step 3, okay, is to use, use y equals mx plus b, or actually we can't use that one. We don't know the y equals mx plus b. Use the slope-intercept form of the line equation, okay? So use, okay, if we know what that is, a y minus y1 equals the slope times x minus x1. That's that line equation. Okay, and then we'll put it into standard form. So there's our slope and there's our point. So the point is going to be where the ones are, and the slope is going to be where the m is. So y minus 7 equals 3 times x minus 1 minus 2. Sorry about my throat there. Y minus 7 equals 3 times x plus 2. Y minus 7 equals 3x plus 6. Okay, now let's rearrange everything so that we have an equation where everything equals to 0 in standard form, or y equals something if you like. If you wanted to add 7 to both sides, we could say y equals 3x plus 13. That's the equation, but if you wanted it in standard form, which would mean you'd have to bring it over here, 0 equals negative y plus 3x plus 13. And there's our equation of the tangent line. Okay, and I would accept this. In fact, I like this form better sometimes. So either of these are right answers. Even if you had y minus 3x minus 13 equals 0. That is also another equation that is the same. These are all equivalent equations, just presented a little bit differently. Say if you didn't want a negative y and you want negative x's instead, that would be fine. Okay, so that takes us to about 33 minutes, I think, because I'm going to give you the practice day tomorrow. I want to do one more of these just to solidify it. Okay, so I'll do one more. So let's say we had y equals x squared minus 5x plus 2, and the point is x equals 1. Find the equation of the tangent line. Okay, so first thing is to plug in the 1. Y equals 1 squared minus 5 times 1 plus 2. So that's 1 minus 5 plus 2. So that's negative 2. So our point is 1, negative 2. We've got our point. Step 1 done. Step 2 is to get the derivative. So this is a 2x minus 5, right? 2 comes out front. 2 minus 1 is 1. And then this is just negative 5 because 1 comes out front. 1 minus 1 is 0. And then that's derivative of that 0. Plug in the value of 1. So 2 times 1 is 2 minus 5. So negative 3 is our slope. So now we have our slope and our point. So now we're going to go y minus y1 equals mx minus x1. Okay, let's plug in our point. So negative negative 2 equals negative 3 times x minus 1. Okay, so y plus 2 equals negative 3x plus 3. Let's bring everything to the left this time. So let's add 3x and minus 3 to both sides. So y plus 3x minus 1 equals 0. And there's our equation of our tangent line. Okay, now I didn't do an example where I said parallel or perpendicular, but if I would have said, for example, if I would have said find the equation of the tangent, I would have said find the equation of the tangent line perpendicular to this. The only thing that you would change instead of putting in negative 3 is you put in positive 1/3. Okay, so I think there's a question or two in the practice ones that do deal with that, but we're going to stop here because that's long enough. That's about 36 minutes. Okay, tomorrow will just be a work period, and I'll have a quick introductory video of which ones to do, and that's all we'll do. So hopefully that was made sense to you, and we'll see you. Well, probably won't see you tomorrow, but we'll work on this stuff tomorrow.